All right, hello, welcome to chapter 13. This chapter is going to be about something called recursion. And at least the basic definition is pretty simple. It's just like a method that calls itself. Okay, so I have a couple visuals up here for you. Like it's kind of like a nesting doll. Like you have an original method, then it'll call itself, and then it'll call itself again, and it'll keep going backwards and backwards and backwards until it hits like a stopping point, and then it's done running. Okay, so it's in some ways it's similar to loop. It's code that runs again and again, but the way it runs again and again is it's a method that calls itself. So these are another sort of famous picture here. They're called like a fractal, where it's just like you make a picture inside of a picture inside of another picture, so forth, down, 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 until you get to the smallest triangle picture, and then you sort of stop. So yeah, recursion is just a method that calls itself. Before we dive too far into this, I want to do a quick review of just like methods in general, right? So recursion is going to involve a method calling itself. Um, but here's just a general method, and I would have you pause the video here and try to answer these questions related to the method here. Just as a review, I think it'll help as we get into the new stuff in this chapter. All right, pause the video, give it a shot. Input parameters are found here. You can have 0 up to, I don't know, a whole bunch. This one happens to have 2. Okay, they're both ints and they're both doubles. Sorry, they're both doubles. One is length and one is width. What does it return? It returns a double. Remember, you can have a void where nothing is returned, but this one's returning the actual area of the rectangle, and that return type is found right here. And then how you would call it from main would be with its name. So I would do find rectangle area, and then I need to pass in the length and the width. Okay, so whatever numbers those happen to be. Okay, and then if it has a return type, it's not void, then you'd want to store it. So I'd want to do like double area, make an area variable and set it equal to whatever is returned by that find rectangle area method, so that the method will run, right? And then once it's done running, it'll store the result in my variable called area. Okay, and you do that when you have a return type here. That's how you call the method. Okay, so recursive methods have two parts. They have like a base case, which is a stopping point, and then a recursive step that makes it simpler by one step, right? So if I go back to this nesting doll example, our base case would be like the stopping point when we hit, say, 2 inches or whatever. And the recursive step would be make a doll that's, say, 2 inches smaller than the one we had previously. So you go 2 inches smaller, 2 inches smaller, 2 inches smaller, 2 inches smaller, until you hit a base case of whatever height that is, and then you'd stop. Okay, so you need, when you write a recursive method, you're going to need those two parts in the method. Okay, and so I think the best way to learn this, honestly, is just to do examples. So if you want to load up an editor and then make a class called recursive examples. So I made a new Java project for chapter 13 programs, made a little package, and then created a class called recursive examples, right? And we'll have a main there, which will be for testing purposes. Okay, so if you haven't already, get that set up, pause the video, and then continue watching. Okay, so the first example I'm going to do is something called factorial from math, which is a number then an exclamation point. And if you forgot what factorial meant, here's just a couple examples. All right. Whoa, sorry, my thing freaked out here. Sorry. Okay, so 5 factorial in math really just means 5 times 4 times 3 times 2 times 1. Multiply all the numbers below 5 going down by 1. And then whatever the heck that answer is, I think that would be 10 times 12. I think that's 120. Okay, and then 4 factorial is just 4 times 3 times 2 times 1, which is, what the heck is that, 24? Okay, and so factorial is a perfect example of how you might do a recursive problem, because if I have, maybe I'll do a new slide here. If I wanted to calculate, say, 8 factorial, I can actually do that by doing 8 multiplied with 7 factorial, right? Because 8 factorial is just 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and so if I wanted to evaluate 8 factorial, I can just do 8, and then this right here, that is 7 factorial, right? That 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so that's sort of the recursive step where I can make it one simpler by saying 8 factorial is really 8 times 1 less. Okay, and then we can continue to go from there. So sorry, I'm making a mess of this, but I have 8 times 7 factorial. Well, I can say 7 factorial is really like just 7 times 6 factorial. Okay, so I can sort of break apart this, right? And then 6 factorial, oh, I can break that apart again. So I have 8 times 7 times 6, and then 5 factorial. So again, I break this apart. 6 factorial is 6 times 5 factorial. And then again, this is just the recursive step where I keep breaking it apart. Okay. And then the problem is I don't want to do this forever, right? Because I don't want to go backwards forever. So I'm going to kind of do a dot, 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 dot. But my base case would be if I finally get to 1, right? So if I get to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 factorial, right? 1 factorial is just 1, right? 1 factorial is just 1. So I wouldn't break it apart anymore. That would be my base case. I would just have 1. 1 factorial is just 1. Okay. And then once we evaluated this, it would go back up the chain and multiply all these back together. All right. So let's look at that in code quick. All right. So what I'm going to do is I'm going to make a factorial method. So I'm going to do public static. Let's do an int and we'll call it factorial. And then n is like the number that's coming into this factorial. Okay. So like we want to do like 4 factorial. So like when I call it from main, I'm going to call it factorial of 5 or whatever. Okay, so that's going to, do 5 factorial basically. Okay, so to do this, I need the 2 parts. So I'm going to do the base case first, and that happens when n is 1. So basically, I'm going to do if n equals 1, right? I want to do factorial 1, right? If I want to do factorial 1, that's just 1. Right, so that's the very basic case that's saying if n is 1, we're just going to return 1. I don't need to like go backwards any further or break it apart. Okay, and then I'm going to do if it's not 1, so this part here would be what we call the recursive step. Okay, and I want to make it simpler by 1 step. Okay, so instead of returning 1, right, I'm going to return. So basically, if n was 5, I'd want to return 5 times factorial of 4, right? I want to make it one simpler, right? And if n was, say, 4, then I would want to return 4 times factorial of 3, right? And then if it was 3, I'd want to return 3 times factorial of 2. And then if it was 2, I'd want to return 2 times factorial of 1. Okay, and then factorial 1 will finally stop, right? Factorial 1 will just return the 1. Okay, so sort of the generic version I want to do here is I want to return the number n that was input here. I want to return that, and then multiplied with factorial of 1 less than n. Okay, so all of these numbers here, 4, 5, 4, 3, 2, 1, is just 1 less than what n was on that time. Okay, so I don't actually need all of these because it's going to do that automatically. Right, so basically my generic case is if it's not 1, let's say it's 4, I want to return 4 times factorial 3. Right, if n is 10, I want to return 10 times factorial of 9. And it'll keep doing that. It'll keep calling itself again and again and again, with n getting smaller and smaller and smaller until n hits 1. All right, at which point it'll just return 1 and stop. Okay, so I'm going to hit the go button here. Actually, I need to either store or print this result. So we talked about factorial of 5 should be 120, I think. All right, so let's see if I actually get 120 there. Okay, and we can do factorial of 4. I think we did that one was 24. So we can kind of just test it, make sure that it's working correctly. Okay, so the idea is, again, factorial 4. When I call it factorial 4, it'll call, maybe I'll break this down just to be 100% clear, right? When this method, when I'm calling factorial of 4, since n is not 1, that's going to return 4 times factorial 1 less than n, factorial 3. Okay, and since factorial 3 is not 1, this factorial 3, right here, sorry if I can handle all the technology here, this factorial 3 is actually going to return 3. That's going to return 3 times factorial 2. Okay, and then factorial 2 is not my base case yet, so I'm going to, factorial 2 will return 2 times factorial 1. Okay, and then factorial 1 will just return 1 because that's the base case, right? So maybe I could draw this out a little bit better. So this will just finally stop, right? I guess I should have stopped here, but factorial 1 will just return 1, and then it'll call it back up the chain. Okay, so factorial 1 is 1, so now I'll do 2 times 1, and factorial 2 is 2. Okay, and then factorial 3 will finish, which will be 3 times factorial 2, so that's 6. And then factorial 3 is now done as 6, so now factorial 4 will return 4 times factorial 3, which is 6, and then it'll return 24. So once it gets to the end, it kind of calls it back up the chain until it prints out the number that we started with.